Assalamualaikum and good day everyone. Today I will present my project entitled Eco Catalyst Coral and POFA-based heterogeneous catalyst for green chemical synthesis. This project focuses on sustainable innovation where waste materials are converted into useful catalysts for green chemical production. So before I continue, I would like to introduce the people involved in this research. This project was conducted by me, Nur Farah Aini binti Mokhtar, under the supervision of Dr. Nurul Ashraf binti Razali. The objective of this research is to investigate the preparation and characterization of heterogeneous catalysts derived from coral waste and POFA. These catalysts are prepared and studied for their potential application in sustainable glycerocarbon production. In simple terms, this study aims to turn waste materials into useful catalysts. Instead of allowing coral waste and POFA to remain underutilized, this project explores how they can be processed and applied in chemical reactions. On the problem statement, glycerocarbonate is an important green chemical that can be used in many applications such as solvents, polymers, and chemical intermediates. However, the production of glycerocarbonate requires catalysts that are efficient, affordable, and environmentally friendly. Many conventional catalysts can be expensive and may also cause environmental concerns. At the same time, glycerol from biodiesel production is often produced in large amounts, while waste materials such as coral waste and POFA are not fully utilized. So therefore, this study addressed the need to convert this waste resource into sustainable heterogeneous catalysts. By doing this, the research provides a greener and lower cost alternative for glycerocarbonate production. For the methodology, the research process can be divided into 4 main stages. The first stage is catalyst preparation through calcination. Coral waste was calcined at 700 and 750 degrees Celsius, while POFA was calcined at 400, 600, and 800 degrees Celsius. This process was done to study how calcination temperature affect the catalyst structure, surface morphology, crystallinity, and chemical composition. The second stage is catalyst characterization. Several techniques were used in this stage. First is SEM-EDX that was used to observe the surface morphology and identify the key elements present in the catalyst such as calcium, silicon, and oxygen. FIR was used to identify functional groups, while SRD was used to analyze crystallinity and phase composition. The third stage is trans-esterification reaction. In this reaction, glycerol react with dimethyl carbonate, also known as DMC, to produce glycerocarbonate. The final stage is data analysis and optimization. The product was analyzed using GCFID, where the chromatogram shows different peaks at different retention times. Each peak represents a specific compound, allowing the researcher to identify and evaluate the reaction product. The proposed solution of this research is to convert coral waste and POFA into sustainable heterogeneous catalysts. Calcination is used to improve the structure and performance of the catalyst. After that, the catalysts are applied in the trans-esterification reaction between glycerol and dimethyl carbonate. Through this process, glycerocarbonate can be produced in a greener and lower cost way. Based on the result, the coral-derived catalyst calcined at 750 degrees Celsius showed the best performance. It achieved 97.20% glycerol conversion, 83.01% glycerocarbonate yield, and 85.40% for selectivity at a glycerol to DMC ratio of 1:4. Meanwhile, for the POFA catalyst, calcined at 600 degrees Celsius showed the best performance among the POFA catalysts, where it achieved 85.10% glycerol conversion, 75% glycerocarbonate yield, and 78.50% selectivity. Also at a glycerol to DMC ratio of 1:4. So this result show that both coral waste and POFA have a strong potential as effective catalysts. And last but not least, the innovation of this project lies in the use of natural and industrial waste materials as catalysts. Instead of relying on the unconventional catalysts, this research uses coral waste and POFA which are more sustainable and cost-effective. So this approach supports with valorization, where waste materials are transformed into valuable products. The project is also original because it combines catalyst development, green chemistry principles, and glycerolization. So this gives the research a strong potential impact, especially in promoting sustainable chemical synthesis. From this project, that it is successfully demonstrate the potential of coral waste and POFA as heterogeneous catalyst for glycerol carbonate production. So the findings shows that proper calcination can improve catalyst performance, and the coral derived catalyst at 750 degrees Celsius give the highest overall result. So overall, this research supports a greener approach by converting waste materials into useful catalysts for sustainable chemical synthesis. Thank you.